Hello, and welcome to this video on substitution used to find the integral of an even function over a symmetric interval. So here we're integrating the function f of x equals x to the 6 plus 1. And this function is even because when we replace x by minus x, we get the same as f of x. Let's see how that follows. Notice that f of negative x is negative x to the 6 plus 1. That's negative 1 to the 6 times x to the 6 plus 1. And negative 1 to the 6 gives us 1. So we get x to the 6 plus 1, and that's exactly f of x. And we have a symmetric interval because we're going from -2 to 2. So the interval is symmetric with respect to the origin. Now here the trick to find this integral is to say that this integral that goes from -2 to 2 is the same as the integral from -2 to 0 of our function, the one that is even, plus the integral from 0 to 2 of our function. And then we can use substitution for one of the integrals. We can say u is minus x, so that du is negative dx. And because our function f of x is the same as f of negative x, our function is even, then f of u is the same as f of x. So we get the integral from, and now when x is equal to -2, u is equal to 2, and when x is 0, u is -0. We get to go from 2 to 0 of u to the 6 plus 1 dx plus the integral, or better, minus du, because dx is negative du, because du is negative dx, and then plus the integral from 0 to 2 of x to the 6 plus 1 dx. But the integral from 2 to 0 is the same as minus the integral from 0 to 2. And we can use this negative sign to change the order of integration. So we have the integral from 0 to 2 u to the 6 plus 1 du plus the integral from 0 to 2 of x to the 6 plus 1 du, or dx, better. And we have exactly the same integral, just a different integration variable, but it doesn't really make any difference. So we have twice the integral from 0 to 2 of u to the 6 plus 1, or better, x to the 6 plus 1, because x looks more familiar. And then dx. This integral can be found by using antiderivatives. Get x to the 7 over 7 plus x evaluated at 2 and at 0. So we end up with 2 times 2 to the 7 over 7 plus 2 minus the quantity x to the 7 over 7 plus x at x equals 0, but we get 0 because 0 to the 7 over 7 is 0, the same with 0. And we can leave the answer like this, or we can rewrite it in a way that we see a fraction. And the fraction is actually going to be 284 over 7. After some math, we get 284/7, and that's the answer. So we can reduce computing the integral over a symmetric interval to computing the integral over half the interval by using substitution. The integral over the symmetric interval is twice the integral over half an interval. All right, this is the end of the example. Thank you for watching. If you have questions, make a comment and I will try to answer your questions. Bye-bye.